All right, on to aqueous reactions and solution stoichiometry. So this is when you are in liquid. So we talked about before, if you have masses of things, how to do the stoichiometry or how to do gases. If it is a liquid or a solution, which most of the time it is in lab, you're going to have to use solution stoichiometry. You're going to have to know what molarity is, because molarity is what we do almost everything in the lab. Okay, so molarity is, hopefully you remember, big M. And it is always going to be moles of your solute over liters of your solution. Okay, so moles per liter. That's our most important unit of concentration. Okay. Also, anytime you are doing a dilution problem, hopefully you remember the M1V1 equals M2V2. Anytime you are diluting something, you can use this equation. Okay, so if I'm changing the concentration, I'm not doing a reaction or anything, I can use M1V1 equals M2V2. So why don't you go ahead and try example number 10, and then I will get into the stoichiometry part. All right, so I knew this was a dilution because I was adding water, okay, to a solution. So I used M1V1 equals M2V2. My M1 and my V1 were 5 and 0.1. And notice for my V2, I didn't use 15 because you need to read the question carefully. It says I added 5 milliliters of this and 15 milliliters of water. So my final volume, or my V2, is actually 20. Okay, so I used 20 as my V2 and got that my new molarity is 0.025 molar. Okay, so now when you go into the titration calculations, this is essentially just stoichiometry with solutions. Okay, this is stoic with solutions. Okay, again, what we'll mostly do in the lab. And in order to do it the same way we do all our other stoichiometry problems with dimensional analysis, essentially all you have to do is use molarity as a conversion factor. Okay, so this is how I would do these. Use molarity, i.e. moles over liters, right, as your conversion. So conversion factor. Okay, so I'm going to do setup number 11, and then you guys can hopefully solve it. So it says, what is the mass of Na2CO3 present? So I'm looking for mass of Na2CO3. That's what I want. In 100 milliliters of a solution, if it required 28.5 milliliters of a 0.105 molar HCl solution to reach the endpoint. So I know that's kind of a lot, so let's break it down. I'm looking for mass of this guy. Okay, that was in, so like this is the volume of that solution I started with. If it required 28.5 milliliters of this guy, so I know how much I used of this. Okay, so a reaction definitely happened. So this is not a dilution problem. This is a stoichiometry problem to get to the endpoint. So that just means it completely reacted. All right, so when you're doing this problem, if you're not sure what number to start with, okay, you always want to start with an amount, usually grams or milliliters or liters. Okay, and you want to start with one that you know the concentration of if it's a liter. Okay, so start with this one. Essentially, I'm going to want to start with this. Start with milliliters with a known concentration. Because if you know the concentration, you can figure out the moles, and then you can use the mole ratio and so on and so forth. Okay, so I'm going to start with 28.5 milliliters. I'm going to go ahead and put that into liters because molarity is moles per liter. So I'm going to do 0.0285 liters of, this is HCl, okay, over 1. Okay, always put your starting number over 1. So that's how much HCl I used. I know the conversion factor because I know it's molarity. So molarity is moles per liter. So it's 0.105 moles per 1 liter of HCl. So it's 0.105 moles of HCl for every 1 liter of HCl. See how those units work out? So my liters will go away. This is how I would convert to moles. Okay. Now you can also do it off to the side, convert using molarity equals moles over liters if you want to. That's fine, but I'm sticking with this way. All right. So now I have moles of HCl. Well, this is what I have, and I want Na2CO3. So my mole ratio is going to be wanted over given. So I want Na2CO3, and I was given HCl. So I'm going to pull those numbers from my balanced equation. 1 mole of this to 2 moles of this. Okay, so moles of HCl units will cancel. So that's my mole ratio. Now I don't want moles of Na2CO3. I want mass of Na2CO3. Now, if I wanted volume, I could use this guy right here, or the concentration. I can use that to figure out the concentration, but I want mass. If you want mass, you need to use molar mass. Okay, so if you have liters, you need to use molarity. If you have mass, you need to use molar mass. So over here, we use molarity, and over here, we're going to use molar mass. All right, so 1 mole of Na2CO3 is, you can add that up if you want to, 106 grams of Na2CO3. Those are going to cancel. You multiply all that out, you should get 0.159 grams, 3 significant figures of Na2CO3.